Alright, so let's look at chemical formulae in this video. A chemical formula represents the composition of elements in a compound. If a chemical formula is written for you, looking at the chemical formula, you'll be able to tell us the type of elements in that chemical formula that is in the compound. Also, you also be able to tell us the number of atoms of each of the elements in the compound. Let me give us some example. See, if I say that, oh, a chemical formula is something like, let me write H2O, which is water. If I ask us how many atoms of oxygen, are present in water? Just one. How many atoms of hydrogen are present in water? That's two. I won't know this if I can't get the chemical formula. So the main purpose of learning about chemical formula, there are two. Check here. A chemical formula shows the following. Why do we have to learn chemical formula? It will let us know the elements present in the compound. If I should ask you, okay, this is the chemical formula for sand, SiO2. If I ask you that the two elements present in sand, they are what? Silicon and oxygen. Exactly. So it will tell you that what are those elements that are present in that compound, you will know with a chemical formula. That is just it. Also, you also know the number of atoms in the what? In the compound. You also know the number of atoms of the elements in the compound. Are we together? Okay, let's look at our common salt, sodium chloride. We have one atom of sodium and one atom of chlorine in common salt. As simple as that. Okay, can you tell me this? If I have something like this, okay, let me say I have can you just suggest a compound for me? Okay, let me say I have this compound. I want to use a common compound that you know. Okay, let me say C2H5, C2, let me say C12, H22, O11. This is a sugar. Now tell me, can you tell me the number of atoms of carbon in this compound? 12. Hydrogen 22, oxygen 11. So that's what chemical formula does. Now, what are the types of chemical formula we have? We have the empirical formula, molecular and structural formula. We'll learn about this in detail in our subsequent classes. And we can learn about all this. You see, our main goal is to learn about this. But you can't know about empirical formula, molecular formula without you knowing how to write chemical formula for different compound. If I tell you that what is the chemical formula for calcium trioxocarbonate for, or calcium carbonate? Let me say calcium carbonate. How we write the formula? So firstly, we must first learn how to write chemical formula for different compound. Then when you know that, we can now move into chemistry finally. So thanks for watching this section. Now, before we learn how to write chemical formula of compounds, we must first understand also atoms and molecules. Now, an atom is the smallest particle of a substance that can take part in a chemical reaction. We've explained this before actually. So remember, how do we identify atom? That is actually the chemical symbol of element. It represents one atom. For example, O represents one atom of oxygen. Are we together? Exactly, that is what it means. So this represents one atom of oxygen. Good. Now, what's the molecule? A molecule is composed of two or more atoms. You see, the smallest particle of a substance is atom. Combination of atom gives molecule. Are we together? That is just it. So a molecule is composed of two or more atoms of different elements, and that is it. Now, the number of atoms you have in a molecule is what we call atomicity. Now, pay attention. Remember we said O is one atom of oxygen. Now, if you see a formula like O2, O2 represents oxygen molecule. Oxygen what? Oxygen molecule. Or you say one molecule of oxygen. You can see in one molecule of oxygen, I'm having two oxygen atoms. Hello? In one molecule of oxygen, I'm having, you see, in one molecule of oxygen, check. How many oxygen atoms do I have? Two. So if they ask you what is the atomicity of oxygen molecule, that is O2, the atomicity is equal to 2. Atomicity represents number of atoms in an element. That's just it. Okay, good. Now, based on this atomicity, we have what we call monoatomic elements. What are monoatomic elements? They are elements that are composed of what? One atom. E.g., let me give you a general example. Metals. Metals and noble gases. Metals and noble gases. Metals and noble gases. You see all these, all of them are just what? Monoatomic element. Any metal you know. Example, metals like calcium, are you there? Magnesium, are you there? Metals like calcium, magnesium, sodium, are you there? Aluminium, okay? All these, in fact, if you can get your periodic table chart, elements in your group 1, group 2, group 3, all these are metals, okay? Good. Our noble gas is group 8. So all these are what? Monoatomic elements, okay? Good. So let me help you and list some. We have lithium, sodium, potassium, are you there? Aluminium, magnesium, and so on like that. So what are diatomic elements? Diatomic elements consist of what? 2 atoms in one molecule. Are you there? They consist of what? Just 2 atoms in one what? Molecule. Example, so you have oxygen, are you there? All your halogens. In your periodic table, if you check elements in group 7, all of them are what? Diatomic. Example of this: fluorine, chlorine, bromine, iodine. Are you there? Also, hydrogen is diatomic, okay? Hydrogen. Good. Now the next one, we have what? Triatomic element. Let me write it here. Pardon me for that. Triatomic element. What do we call triatomic element? They consist of what? 3 atoms in one molecule. From the word tri means 3, di means 2, mono means 1. Example of triatomic element, we have what? Ozone. This is an example of triatomic element. The name is what? Ozone. Good. O3, that's ozone. Lastly, polyatomic elements. They consist of what? More than 3 elements. For example, S8, P4. Are you there? So you can see all these are polyatomic elements, and that's that for that. Now, yeah, let's learn how to write the chemical formulae for binary compounds. If you hear the word binary compounds, bi means 2. They are compounds composed of just 2 elements. Now, to understand how to write the chemical formulae, you must first understand oxidation state. Oxidation states actually mean the charge that an atom carries. That is what we call oxidation state. What do we call valency? Valency means combining power. What do I call it? Combining power. Now, there's difference between oxidation state and valency. See, if I have something like this, Ca2 plus, if I ask you, point out the valency and point out the oxidation state, what will you do? The charge on this element, 2 plus, or you say plus 2, is the oxidation state. So the oxidation state is plus 2. That is it. But what is the valency? To get valency here, you are not to include the charge while writing valency. You just write 2 only. We don't include the charge while writing valency. Okay, valency is just telling you power that is there. That's all. Okay, what if I have N3 minus? The oxidation state is minus 3, and the valency is just 3. That is just it. Good. Now, to successfully know how to write chemical formula of compounds that they call for you, all these are necessary. Everything written here. This one, if you look at your periodic table, you see that these are the group 1 elements. You can see the oxidation state. Please, you have to note them. Write it down right now. These are for group 2 elements. Between group 2 and 3, we have what we call the transition elements. I did not include them because they usually have variable oxidation states. I'll talk about it later. These are group 3 elements. I just listed aluminium. Group 4, well, my main target is on ionic compounds. Those compounds with charges. So it's very rare to see all these there. So let me not include it. So these are group 5 elements, group 6 and group 7 elements. So you can see all their charges, plus 1, plus 2, this plus 3, this minus 3, group 5 element. This is what? Minus 2, group 6 element. This is what? Minus 1, group 7 element. You see, for transition element, like I said, they always have variable oxidation state. For example, copper. You will hear something like copper 1. Copper 1 means Cu. It means that the type of copper that you are having is having a charge of plus 1. That's the meaning of copper 1. If you hear the word copper 2 means that what? The copper we are referring to is the one of what? plus 2 charge. You can see they have variable oxidation state. That is why we must mention the type of copper that we are dealing with. Just like, for example, let me say my name is John, and in a class we have about 5 John in the class. So you have to specify, oh, which type of John. Is it the handsome John you are talking about, or the ugly John you are talking about, or the tall John you are talking about? So you have to specify the type of John you are talking about exactly. So that's just the case with transition element. All together? Exactly. So if I have gold 1, Au plus, gold 3, Au3 plus, you can see tin 2, Sn2 plus, tin 4, Sn4 plus. You can see tin 2, tin 4. So you have to what? Specify that. So make sure you write all these down, and let's now learn how to write the chemical formula. So thanks for watching. Now let's look at how to write the chemical formula for binary compounds. Okay, question 1. If you are asked to write the formula for sodium oxide, assuming you were given sodium oxide, how will you write it? See sodium oxide, how will you write it? Now, firstly, you look at sodium in its ionic state. So what do you have here for sodium is what? Na plus 1. Do you see that? Oxide means oxygen, and that is O2 minus. That is oxygen. Are you there? Good. Now, if you want to write the formula for this compound, you will exchange the valency. That is, the one you see here will come for this one as the subscript, and the 2 you see here will come for this one as the subscript. You won't care about the charge. Remember, valency, when I say exchange valency, we don't care about the charge. Just remove the charge, and just the number is what I need. So let's go. So remember, I have Na. Look at these 2 here. We come down here as the subscript. So you have Na2. Look at this oxygen. We come down here as the subscript. So you have what? Na21. And that's equals to what? Na2O. We don't always include 1. And this is the formula for what? For sodium oxide. And as simple as that. Now, the next question. If you asked to write for magnesium nitride, how do you write it? Now, check magnesium here. You can see that is Mg2 plus. Also, check nitride. Nitride here is what? Nitrogen, and that is what? N3 minus. To write the chemical formula for this compound, this will be done by the exchange of valency. That is this 3 that you see here. Exchange it for this. These 2 that you see here, exchange it for this. Remember, whenever we are talking about valency, we don't talk about charge at all. So we just neglect the charge and just exchange the numbers. Now let's go. Now look at magnesium. What number will I put at the subscript? Look at the arrow. That's 3. Here, what number will I put at the subscript? That is what? 2. And that is just it. And that's all. So you can see this pattern. But take note of some other examples whereby they'll have the same oxidation state. They'll have the same oxidation state. Okay, let me give you an example. If I say calcium oxide, see, if I have calcium, this is, calcium is what? Ca2 plus. Oxide is what? O2 minus. Did you see that? And you can see that, see, once they have the same number, 2, 2, if they have the same number, 2, 2, you don't have to exchange anything. Just write CaO. That 2 will cancel out to just write CaO. That's all. As simple as that. That's all. Look at this one. If I have magnesium sulfide, look at it. Magnesium is what? Mg2 plus. And sulfide is what? Where is sulfide? S2 minus. 2 and 2 are the same. Just write what? Mgs. And that's all. Okay, what of if I have this? If I have aluminium phosphide, look at this, aluminium phosphide. Aluminium phosphide. How do you write the chemical formula for aluminium phosphide? Now, looking at aluminium group 3, so you have Al3 plus, and looking at phosphide, you have a P minus, you have 3 minus, and look at it. So because this number here are the same, you don't have to exchange anything. Just write what? ALP. That's all. So that's how to write the word, the chemical formula for binary compounds. So thanks for watching. Now let's write the chemical formula for this compound. Now look at this example I gave us. This example I gave us actually involve transition elements. So if you observe, like I said, transition elements have variable oxidation state. They will tell you the type that they need. Look at this one, they said iron 3 bromide. Now look at iron, the symbol for iron. Everybody knows that the symbol for what? For iron. Iron is what? Fe, right? So if they say iron 2, it is Fe2 plus. If they say iron 3, it's Fe3 plus. So look at the type of iron now. You have Fe3 plus. So you are going to write Fe3 plus. That's iron 3. Bromide means bromine, and that is what? Br minus 1. All together. So here we exchange valencies. Okay? That is Fe. This one here will come here Fe1. Then I have Br. This 3 here will come here Br3, and that's what? FeBr3, and that is iron 3 bromide. Simple. Next one, copper 1 oxide. Everybody knows the chemical formula for copper is Cu. If they say copper 1, Cu plus. If they say copper 2, Cu2 plus. Okay, good. Now copper 1 oxide, I have Cu plus. Oxide means oxygen, O2 minus. So we exchange the valency. So I have Cu. These two will come here, and this one will come here, Cu, and that's what? Cu2O. You can see chemistry is very simple and interesting. Okay, can you pause the video to try copper 2 oxide out? Okay, after trying it out, let's see what you got. So you have Cu2 plus for copper 2, and oxide is O2 minus. Remember, whenever the numbers are the same, what do? You don't write anyone, just write Cu. Those numbers will cancel out. So as it is, very, very simple. That's that for that. So let us just take some miscellaneous examples. Now I will erase all this. So let us take miscellaneous examples. Okay, what of if you are having barium phosphide? Barium phosphide. Barium is in group 2, just where you have magnesium. So it is like this, Ba2 plus. It is not included because it's not part of the first 30. So, but just take note, barium is 2 plus, and phosphide, is P3 minus. So what do you have? Exchange the valencies. What do you have? You have a Ba, that 3 come here, Ba3, and you have P2. Do you see that? So that's how it is, and simple as that. Okay, who can do potassium bromide? Who can do potassium bromide? Potassium bromide is simple. Potassium is K plus, bromide is Br minus. So exchange valency. See, plus 1 minus 1. See, if you can see 1, 1, the same number, don't write anyone, KBr. So that's that for that. So thanks for watching. Alright, so let's look at radicals. That is, we are trying to go deeper on chemical formulae. Okay, now let's look at radical. They are a group of atoms of 2 or more elements carrying a positive or negative charge. As you can see this radical here is composed of nitrogen and hydrogen. Nitrogen atom and hydrogen atom bearing a positive charge. This is composed of nitrogen and oxygen bearing a negative charge. This one oxygen and hydrogen bearing a negative charge. This one carbon and oxygen bearing a negative charge. This one hydrogen, carbon and oxygen bearing a negative charge. All these are examples of radicals. Are you there? So the positive one are called cations. Are you there? The positive radicals are called cations, while the negative ones are called what? Anions. In fact, in chemistry in general, not only radical, positive ions, we call them cations. Negative ions are called anions. Okay. For example, if I say Al3 plus, that's cation. O2 minus, that's anion, and so on like that. So let's go. Now, examples of them, look at them. So we have to know the name. In case if you want to write any chemical formula and they mention the name, you quickly remember that, oh, they are talking about this. NH4 plus is ammonium ion. SO42 minus is sulfate ion. Are you there? Good. NO3 minus is nitrate ion. CO3 2 minus is called what? Carbonate ion. HCO3 minus is called what? Hydrogen carbonate ion. Okay. MnO4 minus is called permanganate ion. CrO4 2 minus is called chromate ion. And if this chromate is twice, we say dichromate ion. Okay, good. Now, knowing all this already, let's now learn how to write chemical formula that is involving any of this. Now, what you are going to do for me is this. Let's do a task. Write all this down and be looking at it. Okay, so whenever I'm writing the formula, so you actually be cross-checking it. Okay, now let's write. Now, so let's look at how to write the chemical formula for all this. So I've helped you. So I've written some of this in case if you need to make reference to them. So we have aluminium sulfate. So what is aluminium? Aluminium is what? Al3 plus. We've learned that already. And what is sulfate? Now check sulfate ion is SO4 2 minus. Now pay attention to all this. You see, so what you are going to do? You are going to exchange valency. But see the way you are going to exchange valency here. Now check. I say Al, the 2 here on this ion here, you put it here. Like you remember the arrow we normally draw. Good. The 2 here will come here. But if you are writing, if this 3 wants to come here, you know, you are going to put this in a bracket because it's actually more than one atom. You put it in a bracket, then this 3 you have here will come here. This is aluminium sulfate. Did you see that? So when this 3 is coming here, because you are trying to write for more than one atom, you know do something like this. Al3, no, you know do something like this. Al2, then S3, oh, no, we don't do it like that way. So we rather put everything in a bracket. So that's that. Next, for this one, iron 3 sulfate. Remember, this is iron. And if you are saying iron 3, that is Fe3 plus. What is nitrate? Nitrate is what? Look at nitrate ion. NO3 minus. Are you there? Now, let's write the formula. So I have Fe. Remember, this is -1, but we don't normally write 1. Or let me just help you put 1 for practice sake. Then this 3 here will come for this, but you put this in the bracket. NO3, then you have 3. And that is what? FeNO3 3. So what do you call this? Iron 3 nitrate. Because the type of ion that is combining with this is iron 3, not iron 2. That's why in chemistry we won't allow you to just say iron nitrate. No, iron is a transition element. So is it iron 2 or iron 3? So as not to confuse us, you have to do that. You have to mention that. So let's go. Ammonium sulfate. This is ammonium ion. Do you see that? NH4 plus. Then what is sulfate? SO4 2 minus. So I'll write now. Check. These 2 will come for this. Are we together? So I will now put this in the bracket. NH4 2. Remember that 2 is coming for something more than 1. Then ammonium ion is +1. So you just have what? SO4. You know +1, just like you are saying 1. So 1 do not have any effect. So this is your answer. NH4 2 SO4. That is it. Next, tin 4 carbonate. This is tin. Tin 4 is SN4 plus. Carbonate is CO3 2 minus. So we exchange valency. So what do we have? So we have SN2, then we have CO3 4. All together? Good. So that's that for that. Next. You see, in chemistry, we normally do what we call empirical formula. You get there. Where we tend to like divide, because actually you can see these 2. If I should ask you now, what can go between this? You say 2. So 2 here 1, 2 here 2. So we now leave this compound as SN, then CO3 2 exactly. So this is the molecular formula. Good. So you've seen that case. Next, ammonium chloride rather, NH4 plus and Cl minus. So this is what, remember they are having +1 -1. 1 is common, so just write NH4Cl. Okay, good. Copper 1 carbonate, this is Cu +1 and carbonate is CO3 2 minus. So I have Cu2, then CO3 1. So that's my answer. Next, potassium permanganate. What is potassium? K plus. What's permanganate ion? MnO4 minus. You can see +1 -1. Whenever I say +1 -1, just remove them and just write everything together. KMnO4. This potassium permanganate. Next, we have magnesium hydrogen carbonate. So see magnesium, Mg2 plus, C hydrogen carbonate, HCO3 minus. So I have Mg1, this is -1, so 1, then HCO3, this 2 here will come here, HCO3 2. So that's magnesium hydrogen carbonate. So thanks for watching this section. Bye.